In this problem, we are asked, or we're told, the solubility of silver sulfate, and we are asked to find the Ksp of that compound based on the solubility. So we're told that the solubility is 0.0155 molar, and we're asked what is the Ksp. Well, an important thing to start with in this problem is the reaction that is occurring. And so when you have this solid in water at the saturation point, you've reached a dynamic equilibrium where, in this case, 2 silver ions will go into solution, so Ag2 Ag plus aqueous, and then you also get the sulfate ion, aqueous. Okay, so that's the reaction that's occurring, and we're going to use a Rice table to solve this problem. So that's our reaction. We'll need our initial conditions, the change in conditions, and then the conditions at equilibrium. So we'll make our rows, and we'll make our columns. And because this is a solid, I'm just going to leave it out of the calculation. All right. And so initially we're going to start off with 0 amount of these 2 ions, but we know that because this is a reversible reaction and we're at equilibrium, that it's not going to stay that way. There is going to be a shift to the right, so we're going to produce some of the silver ions and some of the sulfate ions, okay? And we're going to get those from this compound, this solid, dissolving. So we're going to lose, let's say, X amount of that silver sulfate. So for every one of these that dissolves, I produce 2 silver ions. So if this is X, then I'm going to put plus 2X in that block. And for every one of these that dissolves, I only produce 1 sulfate, so that's going to be plus X over there. So just like every other Rice table that we've done, we just bring the columns down, and now we substitute these terms into the expression for the Ksp. Okay, and we're solving for the Ksp. So the expression would be, remember, it's products over reactants, coefficients become exponents, and you leave out solids and pure liquids. So one product is silver ion, so the concentration of the silver ion, in this case, is going to be squared because it has a coefficient of 2, times the concentration of the sulfate ion. Okay? And we don't include the silver sulfate because it is a pure solid. Or pardon me, it's a solid. And so now we just substitute in the terms from my E row into these spots in the expression for the solubility product. And so that's going to be 2x squared times x, so that equals, if you multiply all that out, you get 4x cubed. Okay? Now, in order for us to find the Ksp, that's what we're tasked with doing, we need to come up with a value for x. Well, we're kind of told what x is in the problem statement. X is the solubility of silver sulfate. Okay? We said, it says that the solubility of silver sulfate is 0.0155. Well, that's represented here. How much of this dissolves? What is the solubility of this? Well, we said that was equal to X, okay? And so we also know the number there. So the Ksp then is going to just be equal to 4 times 0.0155 cubed. And when you multiply that out, you get 1.49 times 10 to the minus 5. So that is your answer. That is the Ksp of this compound.